Welcome to Blue Ring Stencils here at SMTAi. This is a new name that you're going to see in the industry, and I'm delighted to be joined by one of the partners that made this happen. It's Fred Cox. Welcome, Fred.
Thank you. Glad to be here.
Yeah. So let's just start with the merger side, the business side, because Blue Ring Stencils emerged from a combination of Metal and Fine Line Stencils. Tell us a little bit about that story, how it happened, and how it's going to work.
Sure. Metal Etching technology and Fine Line Stencils were two of the premier stencil suppliers in the States. Mm-hmm. When we looked at it, we had a lot in common, but our geographies were very different. They were primarily west of the Mississippi, and we were primarily east of the Mississippi. So we didn't have a lot of conflict as far as competition. When that started to occur, we started to talk and said, well, why are we doing this? We have some benefits that we can bring to the party on both sides to make a much stronger combined company. Right. Those dialogues occurred over the course of a year, and then as of August 1st, we truly merged.
Okay. So I believe you started off thinking about Florida, but then it went countrywide.
Yes, we started off in the state of Florida, where we looked at it and said, we're both competing in that area. Why do we want to do this? Can we do something together in Florida? And that led to a dialogue about why just do it in Florida, let's just do it across the country.
Right. So what sort of crossover was there in technologies?
It's a good question. We had interesting capabilities as far as the mesh welding technology for bonding the foils to the frame, which they were attracted to and wanted. And they had the NanoSlic gold coating process that we were very interested in and wanted. And so we started looking a little further, and then we found that we also had some stepping technology. Mm-hmm. So the welded step, MET had brought to the market. They were very interested in it. Mm-hmm. They had a milled step process. We were very interested in that for certain applications. Right. So it was a very good technological merger to combine all these resources and then be able to offer them to all of our customers.
Okay, that's good. So looking a bit closer at the step stencil technology that you're using, how are you using? Is that an additive process, or is it, you said, a milling process? Is there a combination of both?
It's actually, there are three ways to step a stencil. One is the old chem etch way, where you chemically mill out an area. The second is the welded step, where you actually laser weld in two pieces of metal of different thicknesses. And then the third is a mill, a micro mill, where you're basically, similar to chem etching, you're relieving an area with a micro mill. They all have their place in the market. There are certain requirements when you're getting a stencil made that will direct you as to which technology is right for you.
Right. But it's still obviously a more cost-effective route than going to electroforming and that type of thing.
Well, electroforming is another technology that, because of the merger now, all of our customers have access to, because we do have that. It's not really displacing electroforming. What it does is it gives you choices when you need to do multi-thickness prints. You have options now that we can tailor it to your needs. It doesn't really have anything to do with electroforming. It really has more to do with achieving a successful print with the best yield.
Right. Okay. So, looking at the other side, at the Fine Line Stencil side, they brought in the NanoSlic coating. How does that work? Is it a permanent coating, or is it one that wears off? And how are you finding that since we've started the merger?
Okay. The first coatings that came to market were truly a nano coating, bonding at the molecular level. The problem with them was they didn't do a good job in the apertures. So they did a great job on the contact side of the stencil of reducing bridging and reducing those kinds of defects. But they didn't do much for the release of the solder paste. The NanoSlic gold coating actually coats the underside of the stencil as well as the walls. It typically will give you an area ratio improvement of about 0.1.
Really?
So it's dramatically better for paste release.
Right.
So if you have micro component requirements, or you're having bridging or defect ratios that are too high, it's a very good solution for that.
Great. Do you do a straight cut on your walls of your stencils, or do you do a trapezoidal cut for paste release?
Almost all lasers have a slight trapezoidal cut, but today the modern lasers, the fiber lasers, it's almost non-existent, but it's still there.
Well, Fred, we wish you every success with your new merger.
Thank you.
And thank you for bringing us up to speed today.
Thanks a lot.